Okay everyone, welcome to my tiny workshop at home, my little shed in our backyard. We have an interesting project on the bench. It has the famous letters 1UZ heavy on it in this metal box. So this is the engine control unit for the Lexus LS400, and it's not my LS400, it's the one belongs to my friend. And people that are familiar with the matter can already tell what might be going on. But before I'll tell you what this project is, little backstory on my friend's LS400. He has a 1993 same build year LS400, same as mine. His is from Spain. It's from this car belonged to the Lexus importer, and it's been very well maintained. It's in very good shape, except for the paint maybe, but that's the Spanish blazing sun for you, I guess. Visited him a couple of times, and he told me that his car had a rough idle and would have a misfire every now and then, and it had some other issues, seeming lacking power, high fuel consumption. I mean high fuel consumption for an LS400, that is. So I believe it did less than 8 kilometers per liter. I'll blink in the miles per gallons here, so it was relatively high. And he asked around, and he asked me for advice, and we said, well, let's start by replacing the coils, and we did it last week. New spark plugs, and checked everything under the hood. Everything was fine. Car started immediately, and the rough idle the car had, an LS400 or 1UZ FE, an original engine, has a very monotonous idle. It runs very smooth, and every now and then, every 5 seconds, it would have a misfire. You could hit a puff in the exhaust and engine would shake and rattle for a bit. That was gone. So we thought replacing the coils and spark plugs was sufficient, and then we went for a drive, and then all hell broke loose. The engine would stall, wouldn't start, would run very nice one moment, and the next moment it wouldn't accelerate, lack of power. So it went in limp home mode. There were no warning lights on the dashboard, but I immediately knew what was going on, and it has everything to do with the capacitors in this ECU. It's a common issue for these LS400s, leaking capacitors in the ECU, and you have the capacitors in the instrument panel that can go wrong, causing the illumination to fail. It starts to flash, and the fuel gauge doesn't indicate anymore. It stays on the empty mark. So what we did, I took this out, I checked it, and I found leaking capacitors. I'll show you. What I did, I ordered from RS Components, no affiliation here, they're not sponsoring me, they offer good service. The new capacitors. It's important that you order the right type. These are all electrolytic capacitors, but they have to be low ERS. So I looked it up in the data sheets for all these capacitors. They come in packs with 5 capacitors each, and I only need about 10, several. Need 2 of, others, the larger one, only 1, but they come in packs with 5 pieces each, which isn't a bad thing because I want to do my own ECU also. What I have here are my 2 wireless soldering irons. I had one at the car, and I have one here in my workshop at home. You can charge them with a USB connection, and I have multiple soldering irons, but these ones are the best I ever had, and they only cost 10 euros each at the shop called Action. The most difficult thing is, I'll show you later on in detail, is how to desolder. So I usually, when I desolder components from a printed circuit board, I use my desoldering pump, which is a hand pump. You push it in and then put a tip on the component or the solder joint, and then you press the button and it sucks in the solder. But for this I bought for this project I bought this soldering wick, Yeah, that looks much better. It's braided copper. It's a ribbon, a wick, and when you make the solder liquid, it starts to run. You can put it on, and it will soak in the solder like a paper towel will soak up water or any other fluid. So first thing we need to do is to take off the cover, and I'll show you what's inside and how the leaking capacitors look. One thing I need to mention is that it's very important to have an anti-static wristband, because anti-static or static discharge can damage the components in here, and if I need to source a new one, it is either hard to find or expensive or both, so I don't want to damage anything. Car did run well, and there are only leaking capacitors. I don't want to do any more damage. So what I did is I have this this socket here. It's an outlet. It has a safety switch. When you pull too much current, and when I have my electric heater on and my compressor starts running, it switches off. There's a fusible link in here, and you can see this green LED here, which indicates it's connected to ground. The normal one you have in your in-home electric system, and I connected this wire, this white wire. Only wire that's connected is the ground wire, the earth wire. Connected it to my Benz, made a connection here, and I have this wire over here. It's a small electric light wire, connected to the blue connector here, and then put the outlet under my wristband of my watch. So this will be my anti-static wristband, homemade. Guess many electricians may laugh at me, because either this might work or or it might be a smart solution. I don't know, but it's the best I can do. I couldn't find a reasonable priced anti-static wristband for this project, but I do a lot more of soldering work to electric components here for my repair business. So I hope this works. So first up is to take the covers off, and I'll show you the inside. Clean up my mess a bit. Put an extra light on there. Hope it shows well on camera right now. Now it's all shielded, so when I don't touch anything, I won't be hurting the electrics, but just for safety, I'll put on my homemade discharge wristband. Alright, let's see what's inside. I looked up on the internet on an OEM part supplier that's located in the Middle East what a replacement, a new ECU will cost, and I believe it was in the range of 1,200 euros. Let's put this there. It's a really nice circuit board. It's double-sided, so that poses a new problem. The soldering pads on here are, well, for modern standards large, but for my poor old eyes they are tiny. So let's get the upper circuit board out, gently pull it out. Don't want to destroy these ribbon cables. You have to be careful with that. This is the lower board, and there are the capacitors. There are several capacitors, several types are ceramic, and I believe these are mica capacitors. These are these tiny, let's say, bins. These are the electrolytic capacitors. I believe there are 8 or 10 in there. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. This is the first gen one you see. I believe later generations and model years can have more, up to 15. These ones are the electrolytic capacitors, and I checked 5 of them, and 5 of them were already leaking. So I'll try to show you in detail now. Get the camera. We have a more close-up view now. It's very hard to show on camera because you have to look beneath, and I can't get the camera in. But what you can see is, let's find one. It's really bad. This one here is. Try to get a camera on there. Maybe an extra bit of light for you guys. Let me get a pointing device. You can see here on the soldering pad, it's ever so slightly. You can find examples of much more worse cases on the internet. But you can see it's like a leaking battery, and everyone has seen a leaking battery at one time. That there's a fluid coming out, it's starting to crystallize. It means that this capacitor is leaking and highly likely not working anymore. This one has a slight miss too. This one, I can see that on camera, but maybe here in this corner, right here, you see a turquoise mint colored decoloration, and that's also leaking. So, and this one here, oh, the camera will focus. This one, the soldering pad here, oh sorry, this soldering pad here, you can also see it's leaking, so I'm going to replace them. I looked up the specifications on the capacitors themselves and then ordered. You can't order any one, they have to have this low ERS. I'll flash it in here, the specification, and you have this, they have to have the same capacity and the same voltage, which is fairly easy to find on the website of RS Components. What is very important is that you choose a quality brand, and these are, I believe, Nichicon. I can read it here, but I ordered from the same brand, and when the Nichicon brand hadn't in stock, I chose Panasonic. So they are the typical A brand Japanese capacitor component manufacturers. So what I'll do next is to remove the bottom side to have access to the soldering pads on the lower side, and then give the desoldering with a desoldering wick a try. So this is the lower circuit board to which the capacitors are soldered. It's double-sided, so we have traces on this side and traces on the other side. It's very easy to damage the soldering pads and the traces on these boards. So I am a bit nervous about this. Let's see how the desoldering goes. Both my soldering irons are charged, so I can work continuously. On the other hand, I don't want to put too much heat in there, but it will be, I guess, a bit difficult to find the bars, the ends, the right ends on this side. Everything is marked on here. Every component has a ladder, resistors, and the small capacitors in here. All have numbers, but they don't correspond to the component on the other side. So, and another thing that will make it difficult, I have to have this upright. Some way maybe I can unscrew these so I can put it upright, so the ribbon cables don't twist and turn too much. So let's give this a try. I'll try my first one off camera, so I don't get laughed at, hopefully. Try to desolder one, and then I'll replace them one by one. I can desolder the whole bunch, but I know myself, I forgot which one goes where. I have to look it up on the internet, make a mistake. One thing that's important that I can show you, I'll get one out of the bag. Let me pick one of the smaller ones. It's important to know that capacitors, they have a positive and negative side. The negative side is marked with a line. The positive side has a longer leg, so you can't mix that up. You have to be really stupid, but ask me why I know. And on the other side, maybe you've seen it in the previous clip and previous scene, each leg, each position of a capacitor on the circuit board is marked. There is a minus and a plus sign, so you have to be really stupid to mix that up. But I'll replace them one by one, so I know what I pick out, check the capacity and voltage, and put a new one in immediately. So I have the first one out. It wasn't easy. I have to get a hang of desoldering with that copper wick. This is the lower side. Try to get it close to the camera, give you a look, but you can see one leg broke off because it was completely corroded, and there's a crystalline forming, some crystals forming, that is a leaking dielectric fluid. So this one's shot, and this one has a capacity written on it, 10 microfarad and 50 volts. Would be nice if the camera would focus, but try it again. There it is, 10 microfarad, 50 volts. So I'll put a new one in here. Oh yeah, I'll also show you, did some small damage. It didn't exactly damage, but you can see I've been working in here. Oh, it looks very worse on camera. These ones, I scratched it because I have, well, my eyes are getting old and I have to put up my glasses. You know, I scratched it with the tip of the soldering iron. No harm done, but doesn't look nice. But I hope my soldering work will not look very bad. So let's toss the first new capacitor in. Well, folks, these are the first two in. This is how they look on the opposite side. You can see I made a small marking with my lacquer marker, white tip on there, because they are exactly the same as the ones I pulled out, so I can trace which one I did and which ones I have to do. So I'll leave the long parts protruding and cut them off later, so I can see where I've been from this side too. So first two are in. I'll continue with the next one. It's fairly difficult. Problem I have with this soldering wick, it absorbs the liquid solder and it burns my fingers. Should have known it's copper wire, it's a good heat conductor, but so far so good. Only difficulty I have is to clear the holes, the vias in this circuit board, clean them out so I can get it through. It's fairly hard. I can't clean them out with a soldering wick. At least these were wooden. So when I put a new component in, the new capacitor in, I have to heat up this pad, push this end through, then heat the other pad, push it through, and then slowly and gently wiggle it in. So far, so good. Let's carry on. So up is number 3 right now. Let's see where it's at and how it's positioned on the board. Top to bottom. Alrighty folks, it's the next day and I had to take a good night's sleep because I was struggling yesterday evening when I tried to solder in, especially had trouble desoldering the capacitors. Current state of affairs is that all new capacitors are in. All the ones were leaking, at least most of them. I'll show you later on. Here they are, 1, 2, 3, 4, 5, 6, 7 and 8. I marked all with a white dot so I know I replaced them, and future repairmen can see, or repairwomen can see, that someone has been kludging with his ECU. Anyway, the one thing I need to do now is to check the conductivity. and with that I mean the conductivity from the upper soldering pads. There are a few, not sure if it will show on camera, but this one here on the right, let me get a pointing device. This one here has a connection up there that runs to this small IC behind there. I need to make sure that the upper part, the upper trace, is connected to the pin of the capacitor. So I'm going to use my multimeter and check for conductivity. I'm going to do this off camera because it might be a bit difficult to get the points, the test leads in. So I'll let you know what the results are. Well, I've checked everything and I'm not entirely sure. When I measure for conductivity, one time the thing beeps, indicating there's conductivity, there's a connection between 2 points on the upper traces. The other time it doesn't. So, and what I also did, I checked and I blew everything out with compressed air to make it clean. And if there are any soldering blobs left, they're out now, so they can't short circuit anything. So the next thing to do is to close the ECU up and give it a test. And if the car won't start and idle at all, I screwed up big time. But when the car starts and runs, I'm pretty confident that we've made a successful repair. But honestly, I'm giving myself not even a 50-50 chance. So let's close this thing up and give it a try and drive to my buddy this week, maybe tomorrow, and I'll show you what happens next. Well guys, here we are at the car. Let's toss the ECU in and see if anything starts to burn. So it's in, it's connected. Now let's give this a try. So we started the car. I had to film it, didn't film it, but it started up immediately and now it's idling very smooth. Now let's have a look on the hood. Everything is running fine. So the next thing to do is to reinstall the ECU on its bracket back into the kick panel under the glove compartment, reinstall everything and then go for the test drive. So we have driven about 25 kilometers now and the car is still running great. It's up to operating temperature. The car is getting washed right now. I feel a slight misfire at this moment. Let's put the AC off. Then it disappears. That misfire remains, so not entirely sure what that is. But okay, let's first wash the car and then continue our test drive. And when we're back at home, I'll give you further tips.